All right, class, on to part two. You'll see now that we've learned how water can move. What about when water sort of holds still for us? Where can we store some water? Where is it available to us for human consumption? You can see here we got some options, right? We have liquid water, we have oceans, lakes, rivers, streams, groundwater below the surface, solid water on the surface. That one's a little tricky. Some of it's permanent, polar ice caps and glaciers, although maybe not as permanent as we had hoped. And then some of that's temporary, right? In Southern California, we definitely depend on that snowpack from up north. And then there are frozen lakes and streams. And we do have gas in the atmosphere, right? Vapor that can change in the clouds and become rain for us, hopefully. Although we've had a lot of rain lately, I'm not sure if I want any more right now. So, oceans. All right. Not very useful for humans. They are the most obvious feature of the planet Earth. You can see we look so very blue because of them. They cover 70% of the surface, but their high salt content makes them undrinkable for us. Also, because the oceans are so vast, they absorb heat very well, meaning that water doesn't evaporate off of them as quickly as it evaporates off of the surface of the earth, of soil, or of plant material. So once water ends up in the ocean, it takes a very long time for it to come back to us in a usable form. And some of you might have heard of the Fertile Crescent. This is kind of that concept that, this is where humanity started. Egypt, Mesopotamia, these are where great civilizations got their start. So you see here we have the Nile Delta, and again, the Tigris and the Euphrates rivers coming together here to create some very fertile farmland and a very nice source of water. So this idea isn't ancient. It continues into modern life. So these are some of the big cities, biggest cities in the world. And you'll see some familiar names on here. I was in Amsterdam fairly recently. It's certainly on a large river. Brussels, Delhi, all these big cities, Rome and Paris, of course, are on rivers. So this, in ancient times was very necessary because there wasn't quite as much water being moved around as there is now. But to this day, many of those cities still rely on those rivers. So there are different types of rivers, perennial and ephemeral. Okay, those are the two basic types. Perennial, sometimes they are called blue line streams. They're called that because they're notated on maps with blue lines. That's because they almost always run the same course. They're there year round and they generally flow in the same channel. And they have riparian zones established around them. So that means that there are plants that are specially, adapted to live on the banks of rivers around them. An ephemeral river or stream, on the other hand, is seasonal. So it's not there all the time. You're not going to find it noted on a map because it's not always flowing, right? This is something that could spring up after just a few heavy rains, or maybe it does pop up every, spring as the ice is melting and you get some of these ephemeral springs coming back or streams coming back year after year. But in either case, they're not there all the time. So they are considered seasonal. We do have lakes and reservoirs. Um, Natural lakes, that's kind of the difference in a sense. lakes are natural reservoirs, are something that's usually human created, constructed, right? So the Great Lakes hold 1/5 of all fresh water. That's pretty insane. I don't know. I've only seen one of those Great Lakes, but it was pretty big, I have to admit. Um, Construction of reservoirs haven't had a whole lot of construction lately, but some of you might be familiar with Lake Mead or Lake Havasu. Even though we call them lakes, they are in fact reservoirs. They were created by humans for the purpose of storing water. I should mention here, this is to address seasonal availability from water sources, right? So in the West, in particular, here, we do have some of these ephemeral streams, right? I think the LA River is a fairly decent example. It's pretty bone dry, or the Santa Ana River for that matter. It's often bone dry during the summer. Maybe the only water in it is going to be runoff from sprinklers, which you sure don't want to drink. And, you know, because that water, even before humans got here, wasn't flowing year round, the West, much of the West is like that. They've looked to store water in other ways behind dams and in reservoirs. So, groundwater is really one of the things that freed humans from living along the banks of rivers. Groundwater is there as long as you don't overdraft it uh, through all seasons, right? So the discovery of groundwater and the technology to use it, right? That's key. Groundwater is one thing, but in very few places does it flow to the surface naturally. Most of the time, it takes a well to get that water. So this is the basic idea of what's going on with the well. Some of you might have had some actual hands-on experience there, but many times they're quite deep. So where is all this water stored? How can we use it? 97.2% is tied up in oceans and salt lakes and seas. So the majority right there is unusable to us. The next biggest quantity is tied up in polar ice caps and glaciers. And then again, we have a third quantity here that's in unreachable groundwater. So that all means that 99.66% is not available for direct human use. So we only have 0.34% of the water that's actually available for us to drink. So that's part of why, despite, take out any drought, take out any lawsuits or legal findings or anything, that right there is enough reason to conserve from my point of view. So, a little review. Where is most of the water stored on planet Earth? Oceans. Doesn't do us too much good. What component of water storage enabled humans to migrate away from rivers and lakes? That's groundwater. It's not just groundwater, but it's also wells to access that groundwater. And approximately how much of the water in the hydrologic cycle is readily available for human uses? I promise not to ask you this on a test, but it is 1/3 of 1%. Okay, humans and the hydrologic cycle. There you go, enjoying some water out there in Vegas. Okay, so are we running out of water? Well, it's complicated. The total amount of water on planet Earth has not changed in over a billion years. That's right, all the way back to the dinosaurs. The hydrologic cycle, as it is here, well, we've altered it a bit. And we've kind of skewed it a little bit. We've disrupted it, shall we say. So things might be a little bit out of whack. For example, groundwater, right? Groundwater has to infiltrate through the Earth's surface, and we have managed to pave over a good amount of the Earth's surface. So you can imagine that we're not getting quite as much infiltration as we used to. So, how do humans fit into this cycle? We remove water in two key areas, okay? Groundwater from wells and surface water, right? We have river diversions. Like I said, we have built dams, we've created reservoirs. So we do take quite a bit of groundwater and surface water. The Colorado River Aqueduct is the biggest surface water project that we're going to deal with. So that takes water all the way from over here out of Lake Havasu and brings it across the desert all the way into this area. This is titled MWD here. That's for the Metropolitan Water District. So that is water that's coming all the way across from the Colorado River, and water that is really the backbone of our imported supply here in Southern California. There is also the California Aqueduct up here. That water is coming from the Sacramento San Joaquin Bay Delta. We do get some water from that, though not as much as we used to. There are some other projects too. There's the Los Angeles Aqueduct that just serves the city of LA, so us in Orange County don't get any of that water. Um, and some other little farming projects down here. But for our purposes, we're really going to worry primarily about the Colorado River Aqueduct and the Colorado River Project, which is the name for all of these dams and series of reservoirs, and then the California Aqueduct. So the Colorado River Aqueduct, we're going to go into this in much greater detail later on, but just know that there are all of these states involved, right? That is 7 states. There's the upper basin and lower basin. And California just barely touches the Colorado River there. But that's enough to give us claim to it, and we actually do take we have historically taken much more than any other state, although that's evening out these days. So small rural wells and community wells do still exist in very small communities. It's hard for us to sort of imagine in a very urban setting, but they do. My aunt up in sort of the, I don't know what you would call that, even the rural area outside of Seattle, they have a well, and it's kind of an issue for them because every time the power goes out, the well used to go out, so they finally had to buy a generator, a backup generator for it. But it's kind of crazy to think that that's how it is. There was a whole community up there being fed just off of one well. And then you can directly withdraw from surface water, right? So that would be literally taking water out of a stream. And then aqueducts and canals for surface water, right? A little more of an engineered approach. And then within communities, distribution systems, that water gets dispersed. So there's quite a lot of ways that we move water to the people. So we have several roles here, right? Or water has several roles, I should say. There's drinking water, there's agricultural water, industrial water, and water used for sanitation. Often neglected, but very important. So, where does the water go back to the cycle, right? So far, we've talked a lot about taking water out, but how do we get it back? So, there is still evapotranspiration, right? You better believe that all those lawns are evapotranspirating. They have a much higher ET rate than most plants, but other plants, trees, shrubs, etc., and also just water that's on the ground evaporates up. Then you have percolation, oftentimes from irrigation, right? You water your lawn with sprinklers, but the lawn doesn't use 100% of that water. By and large, folks tend to over irrigate, and so some of that water does end up back in the ground, which is a good thing. When it rains, also some of that water can end up back in the ground, but unfortunately, the majority of rain just becomes runoff here. So that runoff either enters storm drains or, you know, runoff in terms of like wastewater that gets flushed into the sewer, and then usually emptied into a body of water. So they do remove waste to minimize impact to the environment. There are some alternative water sources. So people have floated these around forever. Um, I suppose the most practical is desalination, although I want to throw a big cautionary note in there because, as we learned earlier in this unit, right, it takes energy to make water move throughout the water cycle, and desalination takes a lot of energy, right? You only see it in places where generally energy is cheap. They have plentiful oil or other resources, or they are so desperate that they have no other option because desalination is so energy intensive, it makes it very expensive, right? The technology exists, but reverse osmosis, which is what's used most commonly, it just takes a ton of electricity. So there's my note on desal. But it is possible. Melting icebergs and condensing water vapor are other options, although you don't really see them used very much at all. From human sources, we can recycle water. So we do see that. Believe it or not, it takes less energy to recycle water to clean our waste stream than it does to desalinate water. So go figure that one out. But in general, it's because of particle size, right? Recycled water, the particle size is a little bit bigger than that salt. Salt is so hard to take out of water. So that's one plus for recycled water. That may come in the form of direct potable reuse. So that would be literally recycling the water and having it go directly back into the water distribution system. We're not quite there yet, but I expect that we'll see that fairly soon. Some people like to call that toilet to tap. I'm totally okay with it. I have drank the water directly out of Orange County's groundwater replenishment plant. Tasted good to me. And then there's non-potable uses like irrigation. Right, so you can see the purple pipes around town. That's water that's often just going to irrigation or going maybe to an industrial use, right? But something that's not getting consumed by humans. And then there's groundwater injection. And I would put a note, it's not just groundwater injection, there's also kind of like the spreading grounds. There's several owned by and operated by LA County and Orange County Water District, where they spread water and allow it to percolate to recharge the aquifer. Here, it's called out as groundwater injection. So that's actually a well that's pumping water down into the ground to prevent seawater intrusion. So all of those are ways that we can augment the water. So here's a little visual of what that seawater intrusion, what those barrier wells look like. You can see that the water table, when it is pumped, if you can imagine this line right here, kind of moves. It's fluid. So as it starts to retreat, it starts sucking up the salt water into areas where, these are your production wells where we're pumping out water. So we wouldn't ever want this salt water to start intruding on our production well. So there's a recharge well drilled in between, and there you're actually able to pump recycled water back in to keep this salt water at bay here. But just to say, that recharge water that you're putting in there, well, do you think some of it gets sucked up by the production well? Of course, right? So we are drinking recycled water. I'd like to re-emphasize that there is no new water. It is all the same water. It is all recycled water, and that's okay. All right, so there it is again, the hydrologic cycle. For better or for worse. We'll do some Q&As now. All right, what are the two main source categories of drinking water supply? Surface water and groundwater. What is the source of recycled water? It is municipal wastewater treatment, right? So that wastewater, once you flush the toilet, once it's gone down the drain, etc., it's treated wastewater that becomes our recycled water source. And what is the name for the process that can be used to convert saline waters into drinking water? It's called desalination. You'll note that it says saline, it doesn't say seawater, right? So you can use that process on any salty water. In some cases, there are parts of the Colorado River or the tributaries that feed into it that have become really salty. So they have tried some desalination in that area. It doesn't have to be seawater, but that is often how we think about it. And that's it for this week. You've made it through both lectures. All right. You will have the opportunity to download the PDF showing you everything here if you want to make some notes on it. So, all right.